Welcome back. This is the second part now to show you guys how to lock out the vacuum advance, or how I've achieved it. There's probably several other ways, but this is how I've achieved to lock out the vacuum advance in an L28 electronic ignition distributor. So what we've got, we go back to here again, we've got the Dizzy, and I'll show you some key points. Now, this point here is where a screw bolt's in there to hold the rod that comes from the dash pot, and the dash pot is this guy, this thing. Where are we? This. So you can see it's got this point here, which corresponds to that point in the distributor. There's a screw that goes in there into that as well, and there's no threaded component there. The rod just sits in here, like the end of this pencil sits in there like that. So of course, as the vacuum diaphragm works, it pulls this rod in and it advances this in this direction and advances this by rotating this plate. So you can see this plate has mobility. Let's move it there, so like that. So as the vacuum works, it pulls it in. As the vacuum's released, it goes back. So that's your vacuum advance. Okay, alright. So what we've done is we've created this guy here is the equivalent of that, and see that hole, see the two holes that I've just superimposed there? They're the holes for the screw, this thing. So what I've done with the housing is normally it would have this nut, this guy, screwed into here like so, and that would hold the diaphragm in place via that hole there. That's threaded. So what we've done is we've taken a drill, a 6mm drill, and we've drilled a hole that starts from there. We've drilled out, we've taken away the thread, and we've gone all the way through, vertically all the way through, and you can see through to the bottom. Okay, and you can see, maybe not well, but you can see in there, oh, kind of, sort of, maybe. There's a whole series of plates in there, but in there we're going to stick this little fellow. So where is it? This one. So the size of this hole here was 2.75mm, and the end of this screw, this is the factory screw, this guy here, is 3mm. So there's an interference there. So what I had to do was I actually had to sit these guys down here. I had a plate, which is this thing, put that on there like that, and then just tap it gently on there, so this would become a zero interference fit. There's no movement in there. Once that's in there, that's pretty tight. That's not going anywhere. Okay, so that's why I made sure that there was no movement there. The idea is to get rid of movement. You don't want to introduce movement by having loose fitting things here. Does that make sense? Okay, I hope it does anyway. Alright, we'll move on. So from here, what we've got to do is, I'll try and do this with one hand. If I had two hands, it'd be brilliant. But I've got to hold the phone. Unless someone can tell me now how they do it with... How do you do videos with holding the phone and doing what you need to do at the same time? Difficult. But anyway, I'll show you. Maybe you guys can get an idea of where I'm heading with all this just by showing you what I'm doing. This guy slips into there, underneath that plate, and will line up with this. It's lined up. Very good. And if you were to look through there, I don't want to... Oh, you can kind of see. Yeah, you can see. If you line up that screw, this thing here that I've had, this guy, you push this now down all the way in through there. You're locking the plate, that aluminium plate at that point, and you put the other screw in here, and you lock that. So therefore, this plate is now going to be locked and it won't move. So I could sort of show you the details of all that, but basically you get the idea. Now the reason why we've got the extra nuts and bolts is, think of it this way. We've got that. I'll take this plate out so you can see. This, first of all, I'll show you. This goes all the way through. Where are we? This goes all the way through. So when you put your plate will sit sort of in the middle there like that. I put a washer on either side of the plate and I put a nut on either side of the plate. So what that means is I can adjust the plates to make sure that this direction is not cocked and doesn't become cocked at some point for whatever reason. So I'm keeping it so it's exactly square to where it needs to go. It's direct, based on the adjustment of the nuts on either side and the washers to keep the plate exactly where I need it. It is virtually in the middle. I think there's a slight bias towards the bottom end. From the top of the distributor to the bottom, there's a slight bias of the plate to be just a little bit lower than center line. But the bottom nut locks on the bottom end of the casing. So that's really good. So the top one is the one that you use to pull down, and actually push the plate onto the bottom nut. And then this guy here is just held in position by the nylock washer guy at the bottom. So it's all pretty straightforward. It's not difficult. It's just like Meccano, man. This stuff, it's really basic shit. Again, totally removable and replaceable. Now, you said, bugger the thread up there. Well, I kind of have. What you could do is you could tap this guy for a bigger thread. Or, alternatively, you don't have to use a 6mm nut. Use a smaller one. Use a 5mm, and then you probably get away with it. But I just had a 6 nut of the right length lying around, and I drilled it, and I thought, well, I'm never going back, so it's not a problem. But if you were, based on this information previously, how I said it's totally reversible, you could use a slightly smaller nut. This is 6mm, as I said, you could use a 5mm and get away with it. But that's how I do it, just with this guy. Piece of aluminium with 2 holes in it. Once it's in place, it can't move anywhere. And I've tried it, and it's locked out beautifully. You put that in there, take that out of course, and put that in there, and its job's done. So there you go, and that locks this guy from turning. That doesn't move at all. Now the position of that, you can change it. You can do whatever you want. The length of the rod will determine where you fix it to. But I had the rod of the length so that it was completely at 0, so there was no advance at that point. So the only advance you're correcting for is the mechanical advance, as I showed you earlier in my previous video. But this one's locked out, so it's at 0 advance from the vacuum advance. There's no addition to that at all. There's really no point in having it in any other position because you're going to have to compensate that by adjusting your housing with your timing light anyway. So just have it so it's all the way back there, and therefore you'll have enough range on your nut there. You can see it's all adjusted to 30 degrees static time because that's what I'm using. It's got that plate almost all the way across. If you run out of movement, you can always undo that guy and adjust it accordingly as well. Worst case scenario is you just change it one sprocket at the bottom on your oil pump drive spindle. The other thing I'll make mention to you now as well, just as something on a side note, and it's not related to what I was talking about. This gap here, where the spindle shaft will go into there, what I've actually done with that, you can't really discern it, but I've actually crimped the end very, very slightly. It's not perfectly H pattern there. And the reason for that is when I put this into the drive, what I was noticing was there was lash there as well. There was slop. So that means the shaft and the timing and everything's not sort of timing itself is, as you accelerate, it retards. As it decelerates, it advances. It does all sorts of stuff. So by crimping that, I've actually got a tight fit. When I put the distributor down, it's actually a fairly firm fit. You can feel the resistance as it goes on. Normally you don't feel any resistance. That would indicate that there's some lash there. But when I put this down, you can actually feel it. So that's another way in which I reduce the lash. Be careful, I guess, if you try too hard, you'll break this. And then you have to, then you have more trouble on your hands. But the point is, if you can just crimp it very so slightly together, which I've managed to do, it helps to reduce the lash there as well. So all these little detail things that you can do to stock Dizzy, and I suspect not only L series, but you could probably do something similar to A series and all the other Nissan engines that run a distributor, that you can just muck around with stuff like that, and you can just try and tidy things up a bit so it's not as loose. It might be fine for a street motor where you're only pulling 130 horses at the flywheel, but when you're trying to pull more over 200 at the wheels, you really need these sorts of things to be addressed. Otherwise, you're just not going to get there. Okay, so that's it basically. Thanks for listening. Thanks for all of it, and I enjoy your feedback as to what you think about all of this stuff. Thank you very much.